You've never seen silicone kitchen tools made like this.
Color starts here. If the ratio is off, the whole batch is trash.
This mill doesn't mix gently. It tears and rebuilds the silicone.
One wrong feed, and you get air pockets that ruin every mold later.
This is the point of no return. Color has to go in perfectly.
They fold it again and again because streaks become weak spots.
See that shine? That's uniform dispersion, that's quality.
Now it's ready, but it still isn't safe to mold yet.
If thickness drifts, molds won't fill evenly, and the product fails.
Next, this exact sheet gets pressed into molds and cured into perfect kitchen tools.
Liquid silicone plus color becomes thousands of tools.
One wrong setting here, and the whole batch fails.
Raw silicone in, perfect kitchen tools out.
And this is how they're shipped by the thousands.
Most people don't know the cure chemistry matters more than color. Too hot, and it warps. Too cold, and it stays weak.
Let's go inside the Silicone kitchenware line. This is where food-grade silicone becomes everyday tools.
Clean room rules first. Contamination ruins everything. Food grade starts with clean handling.
Now the process begins, behind sealed doors. If calibration is off, defects show up fast.
Clean pipes. Clean silicone. Clean results.
Every batch is traced from the first drum.
If the weight's wrong, the ratios won't match.
One stray particle can ruin the surface finish. Texture tells you if the batch is healthy.
Color is controlled like a science. Catalyst is powerful. Wrong dose equals failure.
Traceability means accountability. Now silicone enters the closed system. This tiny filter prevents ugly defects later. Everything waits here, under control. Precision here decides the final feel. Next, mixing with real power.
This room controls color and consistency.
Too much pigment can weaken silicone.
This is where smoothness is made. Bubbles are the enemy. They become weak spots.
This is how they keep it flawless.
Balance matters. A small drift changes everything.
One tweak now prevents rejects later.
Next, the shape is born.
Two paths: injection molding and compression molding.
If the mold isn't perfect, the surface won't be either. This flow speed decides fill quality. Compression is slower, but perfect for big molds.
Pressure and heat must match. Exactly.
Temperature is the king parameter. Get it wrong, and it's trash.
Watch the silicone chase every corner. Robots keep cycles fast and consistent.
Now the cure locks in strength and flexibility.
Leave it too long and it can become brittle.
This is the satisfying reveal.
No tears. No marks. That's quality.
Extra material is cut away cleanly.
A rough edge here feels cheap in your hand.
Waste is controlled and tracked too.
Some tools get silicone bonded to metal handles. Bonding must be perfect, or it peels later. Cooling sets the final shape. Texture isn't cosmetic. It affects grip and release.
Post-cure helps keep food-grade silicone clean and neutral.
If it smells wrong, it doesn't ship.
Next step, make it look and feel premium. Finishing is where cheap becomes premium.
Silicone attracts dust. This fixes it.
Final rinse. No residue.
Color must match, batch after batch.
Two soft bends, two hard cracks. This proves it.
Now it's all speed and rhythm.
Thousands per shift, with perfect timing. A bad seal equals returns. Simple as that. Sensors catch mislabels before they leave. Next, cartons and pallets. Tight wrap keeps packs clean and locked. Robots stack faster and more safely. This step prevents contamination disasters.
If pallets shift, boxes crush. This stops it.
Before shipping, they prove it meets spec.
Strength is measured, not guessed.
Heat resistance is why silicone wins.
Pass means ship. Hold means investigate. Now it moves fast, straight to stores and homes.
From liquid silicone to thousands of kitchen tools shipped out.
That's the full process. Clean, controlled, and precise.
And that's how silicone kitchen tools are made. Subscribe for the next factory tour.